Good evening, everyone. I hope I am audible to everyone.
Yes, sir.
Good evening,
Uh,
sir.
so, Today we are having once again Dr. Kamal for computer organization, and this is our third session of Dr. Kamal sir. So, Kamal sir, I welcome you to the session, sir. You can start the session now, sir.
Thank you, sir.
Yes, sir. Thank you.
I think my screen is visible to all of you.
Yes, sir.
My screen visible. Kindly check it out. My screen is, my slides are changing or not? It's changing?
Yes, sir. It's in. Yes, sir.
Perfect. Okay. Just. Perfect. So in the last class, first of all, good evenings to all of you students. I think in the last class, I'm just giving a recap for our 2 minutes actually what we have done it. And after that, we will just move it further the next session. Because in the previous class, we have just studied about what are the basic funda of computer units, how we can just club it and how we can be able to perform it for an addition, subtraction, how we can perform twos complement, ones complement, how we can align it for the twos and ones complement with respect to addition and subtraction. So these are the special, we can say, the concept that we have studied it. And today, the agenda for our classes is very important or very prominent, I can say, because today we will study about the architecture. What is the architecture? How we can create a particular model. If I'm saying we are just creating, we are constructing for addition or subtraction. So the concept is what is a block diagram that we need try to process it. Okay, so I will just tell you later on, we will study it about what are different type of addressing modes, which is very, very important concept. Because what happen when we are storing a data, there are the multiple types of method for storing a data. But the question is which method that we need to be applied for either for storing a data and either for processing a data, which is very important. So I am just starting with that. Today is the first slide for the integer arithmetic hardware for addition and subtraction. Because in the previous class, if you can see, we have studied about the two's complement, addition and subtraction. But if someone will be says that how we can just perform addition and subtraction on the basis of its block diagram, then how we can be able to process it. So it is a generic diagram. If you can see here, the diagram is, we are having a registers actually, a register and register B. So the beauty of that particular register is every register store 1 bit of data. As I already mentioned in the previous class actually, uh, if everyone is using the especially for the switches at your home, you can just click on that particular switch, it will be on and off. So while we are performing for an on off means we are storing for a 1 bit of data. So if it will be an on, it says the value it will become once. Or if you can do an off, it becomes the value it becomes 0. So for storing for a 1 bit of data, that we call as a 1 bit of register. Okay. So same in this case, we are having a multiple type of uh, registers are existing, register A and register B. So we are having a two types of registers are there. Along with the register, we are just performing the complementary of it actually. Complementary of means we are just complementer, we are using it now. If you can see, we are having a register is here. Complement means we are just converting 1 to 0 and 0 to 1, which is very important. So while we are converting it now, we are just trying to saving it as W. As W stand for switch. Switch is basically used for selecting for addition or subtraction. So the question is, if we are just storing for a data for an addition or subtraction, we need to be take care how the addition and subtraction we need to be performed. After the addition and subtraction, we are using OF. OF stands for overflow bit. Overflow bit means that I just already told you in the last class that if, as you can see here, I'm having a 1, and I'm performing an addition. 1 plus 1, it is becoming 0 and carry 1. So if you can see here, you can store only 1 bit of data. You need to be store only 1 bit of data, but you are having a 2 bit of data. So it means 1, it is becoming an overflow bit. It is called as an overflow bit. Overflow means you are just taking values or bits is more than that particular range, that we call as an overflow. Now later on that you can see here, after the switch, we are just performing an addition. Like you can see here, 1, it is coming from this side and 1 is coming from this side. If I'm just performing an addition, it is becoming a 1 plus 1, it is 0, carry 1. So it means 1 is becoming an overflow bit. This is the thing. And now I'm just coming it out, the most important part, which is very important, I can say, that we call as a machine operations. So many times what is happen when we are just performing for a machine operations, we are just performing for a machine instructions. We need to be take care which type of the machine operation that we need try to process it, which is very, very important. Because what has happened, we are having a lot of operations that we can be able to process it. But the question and the constraint is how we can correlate these type of operations. So if you can see here, the operations of a processor is determined by the instructions. Yes, please understand. Computer instructions. I'm just giving a very, very good example. If you can see here, A plus B, I can say it is becoming C. So A, B, and C, all three are operations. All three are operations. And the plus are equal to that we call as an operators. That we call as an operators. Please understand what I'm saying. If we are having operations and operators, and we can club all the operation and operators, that we call as a computer instructions. That we call as a computer instructions. Please understand. It is saying that we are having operations and operators as well. If I'm just clubbing the operation and operators, and it is becoming a computer instructions. So this is the way that they are just writing here. And this is another instruction they are saying, collection of different instructions that the processor can execute. We can say we are having a multiple number of instructions which are executing by the processor. What we can do, we can just try to process it. For processing of multiple number of instructions that we call as a processor instruction sets. Okay. So next is I'm just coming here. If you can see here that this is a proper cycle is here. That is called as a machine instruction cycle, which is very, very important. Please understand. Because what is happen at the time of the machine instruction, or when we are just trying to processing that particular instruction, there are a lot of questions which are coming in our mind, how we can just try to process it, what the values that we need to be try to do it. And the good thing is there are so many of the instructions that we just try to process it. So the question is, if we are having an elements of a machine instructions, the question is how we can just try to process it. So initially you will see here we are having an instruction fetches here. Instruction fetches we are having a multiple number of instructions are there that we need to try to process it. And after the processing, we are having an instruction fetch. Please understand what is the meaning of instruction fetch, because many times what is happening, we are using an instruction fetch, but the question is, due to the instruction fetch, we are having a lot of difficulty for getting out a data, which is very, very important. Okay. So if you can see here, this is an instruction. Instruction is always be targeting it about the values. Okay, just say I just already told you an example of a plus b is equal to c. So we are having an operations, we are having an operators. So instructions is just like a combination of values which are existing from 0 and 1. After getting an instructions, we are just processing for a instruction operation decoding. The meaning of instruction operation decoding means we are having a lot of instructions are executing, but the question is how we can try to decode it. At the time of decoding, we are having a multiple number of operands are there. So basically, what is an operand actually? Operand, I just already told you. If you can see here that we are having a multiple number of operands, I can say a plus b is equal to c. So you can see here a, b and c are we called as an operands. That we call as an operands. That we call as an operands. Okay. So you can see here, once the instruction is fetching it out, it is directly going for an instruction operation decoding, which is very important. After decoding an instructions, we are just going for an address. Address is nothing. It's just like an when we are storing a data, when we are storing any values, we need a certain address we need to be required. I'm just giving a very good example for an operand's address because if you can see, you are having an umbrella. Almira is here, and you are having a different blocks are there. And every blocks, when you are just storing something, it is having a different number of keys that you are using key number 1, key number 2, key number 3. So multiple keys are representing for an operand address. Okay. So after the operand it is executing, it is directly going for an operand fetch. Operand fetch means how we can just call that particular operand, which is very important. Because what is happened, we are having a lot of instructions that we need to be processed. We have the lot of values which are try to execute. But the question is, at the time of the operand fetch, we need try to identify the values, which is very important. So after fetching it out, we are just going for a data operations, which is very important because we are having a multiple data which are need to be available. And what will happen after getting a multiple data, we need to try to process it. After the processing, we are having an operand address calculation because we are having a multiple addresses which are executing. And after the operations, because we are just performing for a calculation, which is very important. After performing a calculation, we are storing in the operand address. This is an address. So what we can do, we can store that particular values either in the form of calculation or either in go for the instruction address. And after the instruction address, it is going for instruction fetch. So this is a cycle. I can say this is a normal cycle which is going on in order to representing for your values. Yes, it is little bit learning the things, or I can say it is just like mug upping the things, I can say, because it is a process, and for performing any type of process that you need to be try to process, we need to execute, which is very important. So yeah, it is little bit lengthy, I can say, but need to be remembered, which is very important. Okay. Next, I'm just coming it out. I just clean it. Just check it. Okay. Done. So I'm just coming it out the next label of elements that we are just using it now. We can say first is which is very important, or I can say it is very basic, that we call as a laser, we can say machine instruction or characteristics, because we are having a multiple number of characteristics which are executing either for the operation codes, either for the source operand references. Third is for result operand references, or we can say the next instruction operand. So we are having a multiple. Hello.
टेक्नीशियन आएगा
It's a request to all of you, please everyone should mute your mics, or if anyone is having any query, please kindly write it in the chat box. Okay. So if you can see here that we call as a machine instruction characteristics are there, and that we call as an operation code, because in operation code it is always the performing for addition, for an input output that we can perform it, but the OP codes which are existing, which is very important. Second is we are just using for the source operand reference, because we are having a multiple number of our operands are executing. So while we are just performing for an operand or at a time of processing, we need to be check it out which operand that we are using it now, either for input and output, because I just already told you A plus B, which is equal to C. So A plus B are basically the input and our desired outcome that we call as a C. Next is we are having a result operand references, because in the result operand references, we are always focusing the operations, which is very important, because operations may produce the results. And for getting a result, we need to be targeted which type of the outcome that we are getting it now, which is very important, I can say. Okay. So next is I'm just coming for the next instruction references, which is very important, because what will happen in the case of next instruction cycles, we need to be take care that how we can just try to identify, which is very important, how we can just try to process it, how we can fetch the instructions and execute. So I can say these are basically the 4 stages. Stage number 1, 2, 3, and 4. There are 4 different stages are existing. So while we are executing the thing, we should try to follow one after the another. Okay. I think someone is raising some queries. Let's see. Yes, Aditya has asked how we can perform the addition. Aditya, I think you have not attended my previous class actually, because in my previous class, I just already told you how we can perform an addition. I'm just giving an example. Don't worry. If you can see here, how we can perform the addition, just you can just take an example for 1 0 1. I'm having a number and 1 0 0. So I just already told you in the last class that there is a different way of doing an addition. It is having a for rule. If 1 plus 0, it is becoming a 1. 0 plus 0, it is becoming a 0. 0 plus 1, it is becoming a 1. 1 plus 1, it is becoming a 0. Carry 1. Please understand. These are the 4 rules for performing an addition. 1 plus 0, it is becoming a 1. 0 plus 0, it is becoming a 0. 0 plus 1, it is becoming a 1. 1 plus 1 is 0, carry 1. So this is the way I can say we are having a 2 numbers are executing. 1 plus 0, it is becoming a 1. 0 plus 0, it is becoming a 0. 1 plus 1 is a 0 and carry 1. So this is a way for its execution, I can say, because while we are just performing an addition of a 2 numbers, we need to be just try to perform in this manner. Okay. So this is called as an addition for 2 numbers. Aditya, I think it is clear now. Okay. I'm just clearing it now. I think it's a request to all of you, but I'm just teaching extra or I'm just representing. Please try to note down these things, because once you are just creating a notes, that will be a more effective for learning for each and everyone while you're just giving for your exams. Because whatever the examples I'm just quoting it, especially at the time of an examination, your objective or subjective questions, these type of questions will generally be asked. Okay, so you can see here that we are having an operation code. Operation code, I just already told you that is performing an addition at input output operations that we need to be performed. source operand references, because we are having a multiple operands are executing for its operation. And next is the result operand references, because we need to be give a reference for that particular product, which is very important, because we are having a multiple number of instructions that we need to be processed. And next is the next instruction references, because we are having a multiple number of references which are executing, but the question is how we just try to complete it, which is very, very important. Okay. Now I'm just coming it out. The next concept, which is very important or very prominent, I can say, machine instruction characteristics, which is very important, because while we are executing a processing of any type of instructions, we need to be targeted as which type. Please understand, we are at three things. That is an OP code, operand reference, and operand references. So if you can see here, we will having an OP code that we call as an 4-bit OP code which are executing. Okay, so in the 4-bit, we need to be take care which type of the code that we need to be processed. Next is and the operand references, which is very important, because in the operand reference, we need to be taken how many of the bits that we need to be required. Next is the operand references that we call as a 6 bits. So you need to be take care that if you are having a certain number of bits which you are executing, 4 bits, 6 bits, and 6 bits. This is the three we can say addresses that we need to be stored in the form of a instruction representation. Okay, so why we are representing for instruction registers, and we need to be take care for the things in three things: OP codes, OP code examples, and we can say the instruction. We can say instruction examples, which is very important. The OP code, it is always representing for an abbreviations. Please understand, when we are representing in the form of an abbreviations, or when we are representing something in the form of OP code, please take care, it is having a certain abbreviations are there, because every abbreviations, please understand, when we are representing in any form of abbreviations, or while we are need to be take care for these type of things, there is a one thing. Okay, so I just want to say that we can say represented by an abbreviation that we call as a mnemonics. We can say in the mnemonics, we are always be representing in the form of an operation. Mnemonics is nothing. It's just like a code of we need to be just try to represent it, which is very important. Okay, and the second thing is if we are just processing or just we are just trying to executing the things, we need to be take care how we can just try to use it. Second is the OP code examples. What is happen? We are having a multiple number of OP codes are executing: addition, subtraction, multiplication, division, and load. But the question is, when we are just performing these type of operations, we can say there is only for some type of operations that we need to perform. How we can perform an addition, how we can do a subtraction, multiplication, division, and load. Next is the instruction examples. What is happen? We are having a multiple number of instructions which need to be executed. Like if I'm just performing an addition, like r comma y, or we are having a certain, we need to be take care how we can just try to process it. Okay. Next is we are just going for instruction, machine instruction characteristics, which is very important and very prominent for us. Because what is happen? We are having a multiple number of instructions we are having. Okay. But the question is which instruction becoming a very fruitful for us. So you can see here, it is a value contained in data locations. We are having a multiple locations which are executing. Once we are just containing in a certain location, we need to be take a registers as well. We are having a certain number of registers are executing. After adding it now, we need to be to process the result for a register. Either it will be able to process it, either will be able to getting a desired result or not. Next is I'm just taking care of a machine instruction characteristics, because what is happen, we are having a lot of instructions which are executing, but the question is if we are having a 4 phases of that particular instruction type, like arithmetic, logical, instruction type, and input output instruction, and the text and branches instructions. These are the 4 divisions which are executing, but we need to be take care that which instruction that we need to be try to process it. Just take an example. I can say we are having an arithmetic and logic. We need to be take care for data processing. which is very important. Because what is happened, we are having a lot of data which are executing, which is very important. Because at the meantime of a processing for an error, I need to be take care which data it will be good for us and which data it will not good for me. Next is we are just taking for a data storage because we are having a lot of data which are executing. But the question is, if we are having a huge amount of data is executing, we need to be take care how it will be good for us and how we can store the data for the future aspects. And the third is we need to be control that particular data because what has happened, we are having a lot of data to process. But the question is which type of executions that I need to process, either for arithmetic, either for logical, either for instruction, and either for processing. Next is why we are having a machine instruction characteristics. We are having a 4 stages. First is data pre-processing. I can say data processing is there, data storage is there, data movement is there, and control is there. Because what is happened, we are having a data processing is there because we are having an arithmetic and logical units are there. We are having an arithmetic and logical units are there. But the question is, if we are having an arithmetic and logical, how we can be able to just try to process it, which is very important. So please take care while we at a time of an execution or either at a time of processing. We need to be identified at which type of the instruction that we need to be tried to process, which is very important. Okay, next is I'm just taking care of data storage because we are having a huge amount of data which are executing. But the question is, if we are having these type of data which are executing, how prominently we will be able to get a solution? You can see a lot of examples that we are using a clouds. We are using for storage of a drives as well. Why? Because we need to be store a data for the future use. Okay. Next is I'm just taking it about the data movement because we are having a huge amount of data which are executing or accessing. But the question is, if these type of data which are accessing or we can just try to process it, we just trying to identify either for we are having an input output instructions that we need to be transferred, how we can store the memory, what is the results, what is the computational process that we need to be processed because we are just processing a lot of data. But the question at the end, what is the desired outcome? And last, we are just going for a control. Actually, what has happened? We are having a lot of control means it's just like an instructions we need to be processed because we are having a lot of data instructions are existing. We need to be try to process it. But the question is that at the meantime of processing, we need to be try to identify what is the instructions that we need to be processed. What are the instructions? Because instructions means is nothing. It's just like a processing, I can say. We are having a lot of data are existing. But the question is from where we can store a data. How we can just try to process for a certain values, which is very important. I'm just giving a very good example. If you can see here in the Google, when you are searching anything, the Google is providing all the informations to you. So the question is, if you are searching and Google is giving answer for each and everything, can anyone think it about how the Google is giving these things? The reason is why. The beauty of the Google is it is always maintaining a replica for 1:1024 because every value it is having a replica of a 1024 copies. So it means 1024 copies are existing for each replica. This is the beauty. That's why we can be able to easily fetch it out and getting the information very promptly. Next is I'm just coming with the address. If you can see here, we are having a multiple number of addressing modes are existing, either for direct, either for immediate, either for index mode, relative, registers. There are the multiple type of registers which are executing for accessing a data. Now you can see here, I'm just giving an example. If we are having a certain operand is there, operand is nothing in which we can store a value. So operand it is always representing A, B, D, C, E, F. So operand is representing for a certain value. So like if I can say we are having a value of add 5. To add 5 it is representing for an operand. And add is always representing for an operator. Okay. So for add 5 content to a cumulator is nothing actually. Please understand. There are the multiple type of addressing modes are existing. So it is a first immediate addressing mode are existing. Because while we are storing a data inside the instructions, which are having a two things, that is called a OP code and operand. We are having an OP code and operand. The OP code is basically used to, OP stand for operation code. OP stand for operation. Operation. COT stand for code. Okay. So you can say add 5. It means say the 5, it is a content of the accumulator that we are storing, and 5 is an operand. And second thing is there is a no memory reference to fetch a data. Yes, we are not having any memory in order to fetch out the data. In this case, we are not having any storage of data. And next is we are using for direct addressing mode, because what has happened, we are having different type of addressing modes are existing. But the question is how we can just perform addressing, which is very important. So you can see here we are having an effective address. Address field A, add A. So what will happen if you just want to be add something, you should having a certain of type of accumulator that we need to be required. Next is look in memory and an address A for an operand. What will happen? We are having a look in memory at an address A for an operand. Because we are having an address A, add for a content to the cell of accumulator, look in the memory. Because what is happen, we are having an add of A. Add of A means we are just storing a value inside A, and we are having a certain accumulator in which we can store a value for A. Single memory reference and no addition calculator and limited address space. Okay. It is a standard process that we need to process. Now you can see here, if you're just performing for an address instruction, which type of the instruction that I will be able to process it, which is very important and very, very good for each and everything. Like if you can see here that we are using an instructions that we call as an OP code and address, because in the OP code that we call as an operation code, and we are having an address of A. So we are just correlating for an address A with an operand, which is very important. Address A, it is always linking to be this one. Okay. So you can see here, in the case of OP code, so in the case of OP code, we can say we are having a certain address which is need to be executed. Address A is correlated for an operand, I can say. We are having a certain address of A which is correlating for an operand. So it is representing and the exact location where we can store a value of A. Okay. Now you can see here that we call as addressing mode. Operand is held in a register which is named as the address register. Yes, we are having a proper register is existing. We are having a proper effective address, and we can say because EA we call as an R. For EA which is equal to R, it means we are having a certain values which is very important. It is having a limited number of addresses, limited number of registers. Yes, we are having a very prominent number of registers, means we are limiting number of registers in which we can store a value. Very small address field needed, because yes, we are using a very shorter instructions, which is very important. Addressing modes, yes, the good thing is there is a no memory access is required. Very fast execution, yes, we can execute it. Very limited address space is there, because we are having a limited number of address space which are having on it for its execution. Limited registers, because we are having a multiple number of limited registers are executing. And what will happen, when we are just using for a limited address, we can be able to access it. Multiple registers, because we need to be required to check the performances level, which is very important, because I just want to say require for a good assembly. I can say require for a good assembly or programming or compiling the writing. We need to take care that how we can perform the assembly, how we can do the compiling, which is very important. And now you can see here that in the addressing mode, there is another type of addressing that we call it the register. Because in the register, we need to be take care that we add as an OP code and register address of R, which is very important because we are having a multiple number of registers are executing. We need to be check it out, and after the checking it out, we need to be take care that which register that we need to be inclined for a certain operand, because we are having a multiple number of operands which are having on it for its processing, which is very important. Because what will happen, we are having a lot of mentors, we are having a lot of values which are executing, which are having a lot of values which are need to be processed. But the question is, if these values which are executing or processing, I can say, we need to be take care. So in the case of instructions, we are having a one is an OP code and another is a register address R, because in the register address, it is always be representing a value, and the value that will always be come from in the form of bits actually, which is very, very important. That is the values which is aligned. What will happen at the time of processing, OP code is directly aligned with the register. It can add it and directly process in the form of an operand. Now I'm just coming it out the addressing mode, which is very important, because in the addressing mode, there is another type of addressing that we call as a memory indirect addressing. Because what is happen, we are having a multiple number of memory indirect addressing is existing. So you can see here in the memory cell holds, it is having a proper address, because if you can see here, it is having a certain address. And while we are taking an address, it is always representing in the form of just like an array. Like you can see here, we are using the sign we call as an array. It is A representing for an indirect address. It is representing for indirect address. Okay. So in the indirect address, it is always representing for effective address, which is very important. And multiple accessing. But I can say at a time of memory indirect addressing, the issue and the constraint is we are having a lot of addresses which are existing, but the question and the constraint is how we can just try to compile it and how we can just try to re-execute it. So while at the time of re-execution, it is make the things become smaller. Yeah, I'm just coming with a very good example. If you can see here, we are having an addressing mode are there. So in the addressing mode, you will see here, we are having an instruction is there. We are having an OP code is there and along with an address. So the good thing is at the time of an instruction, you can see here that at the meantime of an instruction, we need to be check it out which type of OP code and addresses that we are using. Because in the OP code and in the addresses, we need to be check it out. Either for memory, because what is happened, the address is there. We need to be check it out the memory address that we call as the operator to operand, which is very important because the operator is targeting to the operand. And while we are just connecting on it, it is always be identified for an operand. So if it is having a single memory is there, if it is having a single memory is there, the pointer to operand, and again the pointer operand is always targeting to that particular operand. And next, I'm just coming from the indirect, yes, because what is happen? We are having a lot of registers are holding for an address. Because the query is we are having a lot of addresses are there. We have a lot of values are there, but the question is how we can just try to reconnect it. So you can see here, we are having an effective addresses there for a register. So in the every operand, memory cell is there, which is pinpointing that particular content of a register, which is very important. And after that, we just try to identify which memory access are becoming a faster and what memory location it will be a slower one. Now just you can see here, this is another way of representing for an addressing mode that we call as an indirect. So the beauty of an indirect is we are having an instruction that we call as an OP code, a register address for an R, which is very important. Register is always be targeting for pointer to operand. Pointer is targeting to the operand and so on. So what will happen? We are having a lot of instructions which are executing. So at the meantime of an instruction, we need to be check it out after pointing to the register, how the memory which are need to be try to execute. So it is not a direct address, it is an indirect addressing mode. So you can see here that we are having a certain addressing mode which are executing because what is happen, we are having a lot of values which are existing We have a lot of values which need to be processed. But the question is, if we are having an effective address that we call as an EA, if we are having an effective address that we call as EA and X plus R, and X is a constant value and R is a register value that hold the memory address, and vice versa. So what I can say, we are having an effective addresses are existing for every value, but the question is, for holding an addresses X and R, we are having a certain constant value and it is registered at holding an address of a memory. So you can see here, I am having a value that we call performing an address. It is having a value that we call as a 20 for an R1. Same in this case, we are having an address register. It is having a holding of address we call as a 1000. So next is, if I'm just going for an addressing, if I'm just processing that particular value, we need to be take care which value that I need to be try to process it, which is very important. Because at the time of an executions, we need to be focused on how we can just perform an indirect address. Please understand, we are having a lot of values which are existing for in the OP code, the register and the constant value. But again, the question is, if we are having a register for we are having a value that we call as the register R, and we are just pinpointing for the register R to have one particular pointer that is pointer to operand. So at the time of pinpointing, we need to be target is which operand that we need to be processed that particular value, and the later on what is the desired value that I'm just getting it, which is very important. So please understand, while at the time of addressing modes, we need to be focused on for an indirect mode, because in the indirect mode, it is always the focusing on what is an OP code, what is the register, and how the constant value that we are getting. Please understand, while at the focusing of register, we need to be check it out either it for operator to operand, pointer to operand, or how the constant value which is coming it out for that particular value and what is an outcome for it. Now I'm just coming it out for the addressing mode, which is very important, because in the addressing mode, we are focusing for a program counter that we call as an R, because the program counter will also be existing. And along with the program counter, we are always be targeting for an effective address, which is very important. Because what is happened, we are having a PC value. Please understand, while we are targeting for a value X plus PC is always be standing from program counter, and it is having an X stand for starting bit. It is having a starting address. Okay. So you can see here, while we are representing for an address for a relative, so it is always be targeting for what is the starting point that we are having on it, and what is a pointer counter that we are just targeting now. So while at a time of representing, we need to be take care that what the instruction that we need to be processed, which is very important. First is the format is properly layout for in the form of bit of an instruction, which is very important, because we are having a multiple number of instructions are existing, and the question is how we can just try to process it, which is very important. Next is we need to be include for an OP code because we are having a lot of instructions. We are having a lot of implicitly or explicitly. We are using it now either for 0 and mode. Next is we are using for explicit operand, because what is happened? We are having a lot of operands which are existing, but the question is which operand that we need to be try to process it. Okay, and next is what will happen? We are having a lot of instructions that we need to be try to process, because the question is we are having a lot of values which are existing. We are having a lot of instructions that we are having on it. We are having a lot of things we need to be try to process it. Oply code, implicitly and explicitly, and implicit inducting values which are executing. Next is instruction format. It is for instruction length, I can say, because we are having a lot of instructions which is need to be required, in which we need to be processed, which is very important. It will need to be required for at a time of an execution, which is very important. And the thing is, while at the time of an execution, we need to be try to take care for it. Okay, so you can see here it is a format actually, that is a memory size. We are having a memory organization. And for maintaining for a length with respect to two ratios are existing, memory sizes versus memory organization, and it is having a length that is a bus address, processor complexity, and processor speed. So it is a proper format which is executing for an instructions. And now, while at the time of an executions, I need to be take care which size, how much the data size which is executing. You can see here we are having a greater flexibility because we are having a multiple flexibility of data which are existing. But the question is how we can just try to reuse it, which is very important. For example, for the reusability of a data, more OP code, more operand, more addressing modes, and greater addressing ranges are using. Because what is happened, we are having a lot of instruction, a lot of operations, lot of addressing modes are used to be used. And but the question is how we can just try to getting an optimal results. Okay. Next is I'm just trying to getting for an information. What is how we can just increase that particular value, which is very important because we are having a lot of main memory size and use of virtual memory, which is very important. Because the question is as per the approximation at the possibility of values, we need to be try to check it out how we can increase that particular value or how we can decrease that particular value. Next is I'm just going out for the instruction format, which is very important because what is happened, we are having a lot of instruction formats are there, but the question is how we can perform the allocation of a bits because we are having a lot of allocation bits are existing, which is very important. Either for 4 bits, 6 bits, and 10 bit certain values we are having on it, how we can just try to process it, which is very important and prominent for us for learning. More OP codes, obviously the mean more OP code which are used in the operand field. This will reduce the number of bits available from the address. Yes, we are having a multiple number of bits that we are existing. We are able to process it. But the question is, we need to be try to check it out. Whether we are getting a results, it will very prominently or not. What is the effective outcome? What is, I can say, what will be the outcome that we need to be try to process it, which is very important. Now, we are having a certain number of instruction formats. You can see here, there are the multiple number of instruction formats which are existing. But the question is, which instruction formats are good for us, which are more prominent for us, and what is the effective outcome? So you can see we are having a lot of addressing modes, number of operands, number of registered sets, addressing range, granularity, register versus memory. So the question is, if we are having a multiple number of things are existing, we need to be try to check it out, how effective and how prominently we need to be try to process it, which is very important and very effective for each and everyone. Now we are having a processor organization, which is very important because in the processor organization, the good thing is we need to be try to fetch the instruction because initially we are fetching it out, interpret the instructions, fetching the data, process the data and write the data. So this is a one cycle which is going on, and after the execution, it is storing a data for the future use. Because while we are just why we are storing this particular data, the good thing is for storing a data, we are using it for the future use, which is very important. Now you can see here, it is having an arithmetic and logical units. We are having a lot of data which are existing in arithmetic and logical. There is a called as a status flag, shifter flag, complementer flag, arithmetic and logical units are there. 4 different units of flags are existing, and we need to be take care of internal CPU buses while we are using it because all the flyers are directly connected to that particular of internal buses, which is very important. Or while at the meantime of an execution, we need to be take care that which register that we need to be execute. Because if you can see here, we are having internal buses are existing, internal CPU bus. We need to be try to check it out, how we can connect it, and later on we can do control bus which are executing is directly connecting to that and finding out an optimal solution. Okay. Now I'm just going for the register organization, which is very important because at the meantime of user visual registers, I need to be try to check it out either we are getting a prominent results or not, because what is happen, we are having a lot of values are existing, which is very important, and we are just trying to processing it now. Because we are processing the multiple values, but the question is, at the meantime of processing, at the meantime of getting a values, we need to be try to check it out what will be the user visual registers are existing, which is very important. So we need to be take care that which value it will be a visual registers, how we can just try to connect it, and how will be the optimal solution for our problem statement. Now you can see here user visual registers. It means we are having a general purpose. General purpose means we are having a data which is having a general purpose that we can't be able to use it to be everywhere else. Data is here because what is happen, we are having a data which is it is only for in the form of bits. We are using for an address, which is very important, because every address which is having on its in the form of plus minus multiply, it is having a proper location is there. And next is conditional codes, because what is happen, we are having a lot of code which are existing, but the question is which type of the condition that I prominently that I will just prefer to use it. Please understand the conditional code is nothing, is just like a situation. Suppose I'm just executing a certain situation, and at the meantime of situation it is having a some halting situation is there. It means our certain condition is become halt, or either it will be go for infinite waiting condition, or either it will be stop for certain situations. So I can say it is always depending upon the situation that how we can just try to use it. Next is I'm just using for control and status register, because what has happened, we are having a control and status register means we are having a certain values are there, in which how we can just use to control that particular value, what is the status, what is the value which are existing, how we can just try to process it. So these are called as a register organization. So at the meantime of registering an organization, we need to be take care. What is the program control? What is the instruction register? Memory address register, memory buffer register. So these are the certain values that we need try to be check it out. Either these values are giving a very prominent result for us for its execution or not, which is very important and very helpful for processing a data. Now you can see here it is a cycle. I can say we are having a certain cycle is there because it is called as an instruction cycle, because the instruction cycle it is always be focusing that how we can just fetch it out, how we can interpret it, what is a direct or indirect execution for it, and the thing is how we are getting a fruitful outcome. Please understand when we are having an instruction cycle, because instruction is nothing in this particular universe, whatever the data, whatever the values we are having on it, it is having a some cycle is here. Cycle means it is a process. Can anyone tell me what is the meaning of cycle? Cycle is a process which can repeat it in every instance of time, and at a one cycle it is not having any starting and ending point, that we call as an instruction cycle. You can see the water cycle, nitrogen cycle, oxygen cycle. There are the multiple cycles are existing, but the thing is, in these cycles there is not having any starting or ending point. So you can see here, first is we are fetching a data, we are just getting a certain input. We can just try to interpret it, what is the desired outcome, which is very important. Third, we can just try to execute it. And fourth, we can say we can having an indirect. So I can say all the things which are correlated to each other for getting an outcome. For getting an outcome. And next, I'm just coming it out and the instruction cycle in a detailed manner. So if you can see here, we are having a certain CPU. CPU stand for control processing unit is here because we are having a CPU is existing. Because in the CPU, you can see here, we are having a program pointer we are having on it. Memory address register is there. Control unit is there. MBR stand for memory buffer register, which is very important because buffering, please understand, there is a word we call as a buffer. Buffer is nothing, it's just like storing a data in just a manner for the future perspective. Because buffer is nothing, it's just like a, we can say Google Cloud. Because of Google Cloud, it is having used to storing for huge data, but the BMBR is basically used for storing a data for a small data set. And IR stand for instruction register, because instruction register is always focusing on set of instruction that we need to be processed. And there is parallelly, there are the three buses are there that we call as an address bus, data bus, and control bus. These are running it parallelly, I can say, and all are connected directly to the memory. Again, while at the time of instruction cycle, because we are just executing for an instruction cycle, we are just processing for an instruction cycle, we need to be take care that there are three things which need to be processed: memory address register, control unit, and MBR. Please understand, the beauty of these thing is all the three buses are connected parallel to each other. So whatever, if you want to be execute certain instruction, if you want to just process a particular instruction, we need to be used at particular memory, which is very important, and you just try to connect it parallelly. What is happen? If one is not working, it is go for another and it's going for another. So this is less like a, we can say all are connected to each other. Same in this case for instruction cycle. What will happen? In the instruction cycle, we are having a CPU, PC, MAR, and we can say the control cycle is there, and what will can the BR is there. You can see here in the instruction cycle, we are just connecting it now the data. Control unit, MBR data is here, and the MR data is here, and the memory is here. Okay. So what will happen? We are having a multiple number of data which are existing. What will happen? We need to be try to process it. So you can see here when the huge data is existing, we can say we are having a huge data is here. But the question is how we can just maintain a flow of a data between the different buses are there, which is very important. Now I'm just coming with the which is called as a very last slide. I'm just coming it out because what will happen? We are having a lot of data sets are existing. We are having a different type of instruction cycles are existing. But the question is, if we want to be working of an instruction cycles, you need to be take care which type of instruction cycle that you need to be take. There are two type of instruction cycles are there. That is called the RISC and CISC. RISC is basically used. RISC is basically used to reduce instruction sets computer, because it is always be targeting for reducing instructions. Okay, use for a limited set of instructions and processing the instructions in the form of pipeline. Because what is happened, we are having a lot of cycles are existing, but the question is how we can just try to process it, which is very important. So in the meantime, we need to be target either we are having a large number of journal cycle registers are there, how we can use it, how we can optimize the register for large usage. Next is limited simple registers, because what has happened, we are having a lot of instructions which that we need to be try to process it, which is very important, and it is very prominent for everyone. Third is emphasizes on optimizing the instruction pipeline, because we are having a lot of instructions for pipelines. Pipeline is nothing, it's just like we are having a lot of processes that we need try to process it. At the end, we just trying to getting a desired results. Okay. So this is all for today. If anyone is having any queries that we can just take it. If anyone is having any query for a today's session, any question that you are having, so please kindly ask me any queries. But it's a request to all of you that whatever I am just teaching, please try to work on it. And in fact, I will share the PPT with the sir also. So I will share this PPT to the Sandeep sir as well. Okay. But my question is, please try to study it, try to focus for a one book that in the last time I just already shared a PDF link. The link name was Morris Menu. There is an open access available that is a free of cost. Please try to study it. Why I'm saying, because this subject, it is not only for clearing your exam. Please understand. Because everyone will be the pass for your exam, but the question is there are some subjects in your life actually whatever you studied, it will be inclined for a whole life, we can say. So it's a request to all of you, because design, computer organization architecture, design architecture, system architecture, advanced computer architecture, which are all coming in the one platform. Oh, and we are all basically for data sciences. We are all for working for an IT. It will be used in everywhere. So please understand, these are the basic things that you should be learn and you should be remember. And these are the basic concepts. But it's a request to all of you, please, not only studying a paper, it is not only for clearing an exam. Kindly study it about, especially for these things, because if you can go for your curriculum, it will, I just wind up it within a 2 or 3 or 4 classes. But why I'm just going in so much detail? Because these are things are really very fruitful. And it is very knowledgeable. If you are just going for an interview, these are the basic questions that will be asked at that particular time. Okay, so it is all for today. I think I just already shared my mail ID with all of you. Again, I am sharing. In the last class, I think in this week, I just got 2-3 mails from your student side that kindly help it out for giving some notes or some queries. So I've just help it out if someone is having any query, anything that you want to be discussed or anything that you want to be say. Yeah, I'm having this mail ID that you should drop a mail and we can just directly revert off your queries here. So it is all from my side. Sandeep sir, are you there?
Yes, sir.
So
The session was good, sir. And it's Norris Mano is a wonderful book. I request all the learners, if they don't have the link, I will share the link with you,
yes, sir.
and you can download that book as well.
Sir, in fact, in the last class, I already shared a link with all of you.
Yes, yes.
You can say I wish. Otherwise, what I can do, I share a PPT with you and along with a downloaded copy on your mail
Right,
ID.
sir.
Okay, sir.
So no problem, because few learners have recently joined this program, and
Okay.
I think 20, 25 learners.
So,
So I
sir,
will share with them.
sir, what I can do, I will share a PPT with you, sir. And plus, I will share a downloaded PDF copy for the Morris menu, so you can just share with all of them, sir.
Right, sir.
Thank you. Thanks a lot. Acha, please share a link on this community. Just a minute. Just a minute. I am sharing. Yes, I'm sharing a link with all of you. Please, everyone should try to download this particular book. It is a very good book, or we can say it's just like a Bible for computer organization and architecture. In fact, at my time, I studied this particular book. Okay, this is the best book actually. इससे better book कोई नहीं है. Sorry to say. So please, everyone should study this particular book. In fact, if you can see my PPTs, if you are thinking my PPTs are very good, I will say all of the content I am just taken it from the Morris menu. Okay, so it's a request to you. Everyone should try to read this particular book. It will help you out to upgrading your personality, especially for reading this particular. So it is all for today. Thank you. Thank you, sir.
Thank you so much, sir. Thank you so much. Thank you so much, learners, for joining.
Thank you.
And you join session again at 7:30. We are having another session. So thank you so much, sir.
Thank you, sir. Thank you. Have a nice day. Thank you.
Okay. Yeah.